Okay, here we go. So I am going to be talking about the fiot-sensor-server, which is I should say this, it's a Node.js based server on top of sensors, Python-based sensors. So just to acknowledge this, this was written by Parker. I've done a little bit of fiddling to add some functionality, and then I kind of also made it uglier. So it was very elegant when Parker was responsible for it, and apologies for some of the ugliness, but it's still pretty good. I haven't ruined it completely. And this is where you get the code. So it's at gitlab.com fiot-sensor-server. And so what is this for? The basic idea is you have some Python drivers for some sensors that are connected to a Raspberry Pi, and you want to access the sensor data from those sensors via HTTP. And why would you want to do that? Well, if you want to use a GUI that is browser-based, so you want to bring that data into the browser, or if you want to access the data remotely, having a server on top of the sensors is a nice way to do it. So, and just to say, this is something that you could also do something similar with Flask. One of the reasons for using Node is that it allows you to access sensor data asynchronously. There are a lot of people who know how to generate Node servers and mess around with them. And there's some other fun tricks I think that you can do with Node that isn't so easy to do with Flask. The other thing is that, as Parker pointed out, if you have a lot of Python code for talking to sensors, at some point, if you want to use the browser, you have to kind of speak JavaScript at some point in order to deal with that data in the browser. So running this Node server just sort of makes that choice at the server level. So you're running the server in JavaScript, and then the rest of your chain all the way to the browser is JavaScript. In any case, this will all be a lot easier to understand if we just show how to install it and use it. So what are the prerequisites? You're going to need Git. You're going to need the latest version of Node. You're going to need to install pip. And you're going to need to install a virtual environment for Python. And then down the line, I'll also show you we need to install the PySerial module. But okay, so let's just get started. So I've already installed Git, and on an Ubuntu system, which I'm going to be demonstrating, that is just sudo apt-get install git, I believe. You can check. Getting the latest version of Node, you don't want to use the one in the don't use the standard Ubuntu repository version. It's too old. So you want the latest version. And a nice tutorial for how to do that is on DigitalOcean. And if you just search for DigitalOcean and how to install Node.js on Ubuntu, you'll find that tutorial. So I've already installed Git, I've installed Node, I've installed pip. So why don't we, and I've also installed virtual environment. So I'm going to start at the point where we're cloning the repo. So I'm going to do this in my documents directory, and I have a bunch of other folders in my documents directory, but so we're going to add a new folder by cloning this repo. So I copy this URL, copy that here, and I'm going to say git clone, and there we go. So that's pulling that down. And now you'll notice that it created a new directory in my local folder here in Documents. So I'm going to change into that directory. And quickly, I just want to show you in terms of the structure, you can sort of ignore these for now. Those are just some parameters to help Node NPM figure out what to install when we install this package. this is a utility Python function that we're going to ignore for now, that we don't have to touch. This is the node server that we're going to be running, and then this is where our customization really tends to occur. This is a directory that is called sensors, as we see. Oops, sorry. And so if we look at this, I've got two sensors in here, two sensor drivers. And these sensor drivers need to follow a standard format, but you can wrap other Python functions in this standard format, and I'll show you what I mean. So if I look at temp.py, the standard format that I'm referring to is to have a class that is named something relevant to what you're trying to measure, and that class should always have a method called getReading, and that getReading function will have this form where it does some computation to get a reading, and then it returns that value. So maybe it would be even more, and I don't need to sleep here, that was just for another test, but I could say temp equals, and this could be some Python function. Perhaps I had my own custom temp sensor module that I'd written or that I'd inherited from somewhere, and this could be something like temp equals temp sensor module dot get temp, because maybe there's a function called get temp inside that that module, and then but in my case I don't have that, so I'm just gonna use this random number generator just for now as a test, and then return temp. So that's a pretty generic way to do this, and I'll also get rid of that non-existent module there. But okay, very good. So that's kind of the general form. You have to define this function. This is where you could bring in your own function for reading the sensor. So somebody wrote a Python script for reading a temperature value from a DHT22 sensor, what have you. This is where it would go, and then you return the value. Okay, great. So now we've got that function there, and just to show you, like I'll also add another one. So let's copy temp to light.py and edit that one. So now I would call this something reasonable like light sensor. I'll keep this get reading function, and now I'll call this light and just generate a random number, and I'll return light. Those names don't matter, but it's just clear in the function. The key thing is that you need this function to be called get reading, and that's what the system's going to be looking for. Okay, great. So now we've got three functions here, each of which is a driver for a particular sensor, and all of those are in the sensors directory. So now when I go back up, I'm back in the main directory here, and the main action here is occurring in the node server. So let's just look at that for a second. So in this code here, there's a bunch of stuff, like I added a couple of things, but you don't really need to worry about what's happening up here. That's going to remain the same no matter what sensor drivers you add. But just to show you how this works as a server, this server application has routes, and this is sort of similar to if you're familiar with Flask, how Flask works. You define a get route here, this way, and this means that preceded here by our IP address, so it would be like your local IP address in terms of what you'd be navigating to, you would type into a browser your local IP address, and then you could hit /list, and then your browser would get this function, and this has been written in such a way that it will list all of the sensors that we have available in that sensors directory. And this one will get, and if we go to our IP address /sensors/ the name of a particular sensor, that will get the value from that particular sensor. This function will return, the route / all will return all sensor values, and that's how this is structured. And you could do custom things, but for now that's basically how it works. I added a function just to return what our local IP address is, and that's me hacking around, but that's the core. So you can kind of ignore this part. This is where the action is in these functions down through here, and then you can kind of ignore the IP address part. Okay. So that was all in index.js, and let's go back to our procedure here. So I've installed pip virtual environment, and I've cloned the repo now. So what we want to do before we install any additional modules in Python is to activate our Python virtual environment, and that will make sure that everything that gets installed, it gets installed to the right place. So how do we do that? We create first a virtual environment. We call it venv, and so here we go. Virtual environment venv. That takes a second, so we're waiting. Okay, great. So now we're set. And then to activate that, we type this, and this is a custom name that I've come up with for this virtual environment. You could create whatever you want. Call that Bob, say, and then this would be source Bob, but I've decided to do venv and venv. Okay, very good. So activate it. So I'm going to activate it with this command here. Boom. Now if you notice, what that has done is, before my command prompt was always looking like this, now it's preceded by this material in parentheses here, and that's indicating that we're in the virtual environment, and everything that we install from here on in will be in the virtual environment. Okay, so then I want to install PySerial, because I had added a module that depended on PySerial. So I'll do that. Okay, that's great. And now we're ready to install the node module, the fiot-server node module. And that you just do by typing npm install. And notice it's important that you run the virtual environment first, because this node module has some hooks that are going to install some Python scripts and modules, and you want them to be installed in the right place and have the right permissions. So npm install. Okay, so now it's fetching that module and all of everything else it needs. Okay, great. Looks like that worked. And before I run this module, I just want to check my local IP address. So hostname -i. Great. So that's my local IP address. Now that's going to come in handy in a second. So now I'm going to run the server. There are two modes. The straightforward way is to just type node and then index.js. But preceding that with this allows us to see any errors that our Python code might throw. And that's useful for debugging. I'm going to hope that everything just works at this point. So for my first pass, I'm just going to type this. So here we go. Node index.js and go. Okay, so it's telling me that there is an example app listening on port 3000. And so I'm going to navigate to that IP address and port 3000. So let's do that here now. So there's the IP address, port 3000, and I don't think I've written in the server anything to just respond to this particular address. What I had written was a route for list, for example. So why don't I do that and see what happens? Okay, great. So it turns out that Firefox is pretty sophisticated in interpreting JSON, and it nicely gives me a table. But this, just to see the raw data, this is what my server had returned, was a list of the various sensor drivers that I had in that sensors directory. So let me just open another terminal so we can reference that again. So it had actually pulled out the names of these drivers, light, serial read, and temp. So you can see those in this list here. Now, if I hit all, and again I look at the raw data, it's sending me back a JSON structure that is the latest readings coming off of those sensors. So it actually activated those drivers and responded. Now, I had written a random number generator for light and a random number generator for temp. It turns out that I actually have an Arduino connected to a USB port, and that's reading off a serial value. And I can go into that in another screencast, but at any rate, all of these drivers are now reporting. And just to show you, this is what the serial read code looks like. So that's something you can play around with. Okay, great. And then the final thing here, I guess, to show is that, so I had list, and then I believe that the way the server's written is, you could say sensors, and then the individual sensor name, and then the raw data that'll come back is just the value from that sensor. So that's pretty much all the functionality of the sensor at this point. The use would be that in any browser that can connect to this IP address, or really any other server software that could, or a curl command, you could now address an individual sensor through this URL, as long as this node server is running. So that's something that you might imagine spinning up on a Raspberry Pi alongside whatever other server you have, running this server on port 3000, and then when you have a Blockly or a Node-RED application, you can use an HTTP GET command to the appropriate URL to pull sensor data into that web framework as you like. All right, that's about it. I'll be posting all of this data with all the instructions separately along with the video, so that you can follow it if you need to. Cheers.